All right, here we go. Okay, folks. First problem is from last week. We're getting into factoring this week, and we started with factoring by the greatest common factor method. So we need the GCF, greatest common factor, between these two terms. We've got a 28 and a 14. I'll show you the long way to this. If you list all your factors of 28 and all your factors of 14, you get 1 times 14 and 7 times 2 here. Here you get 7 times 4, 2 times 14, 1 times 28. You can go in your calculator under y equals, and you can type in any number you like, divided by x, and if you go to the table and scroll up and down, you can see all these factors. What you need to know is that on a standardized test, this would probably be calculator inactive though. So if you can figure out your GCFs without the calculator, that's the best. So after we list them, what we're doing is we are picking the largest factor that shows up in both, and that's going to be 14. The other thing I do is I find the smallest number in all of my terms, and I check to see if it'll go in the others, and if it does, that saves me a lot of time because that means that's the GCF. So in other words, I would see the 14 and say, okay, does 14 go into 28? It sure does, so I know 14 is the GCF. Okay, variable-wise, the variable has to show up in all the terms. X does. So I pick the smallest power that's up there, and that's going to be x to the first power. Does y show up in both terms? It does. So I pick the smallest power up there, and that's y squared. So the correct answer was B. Okay. Okay, bringing back average rate of change, because we've got to know how to do that. We should know by now you are just calculating the average slope, because and they have to give you a specific interval because the slope is different everywhere unless it is linear. So this is not linear. So average rate of change from x is 3 to x is 6. Well, x is 3 is right there. X is 6, hits right here, and if I am going to do slope, I can easily just do rise over run. I mean, you could write these as ordered pairs and do, but it, would take a lot longer. So we're going to do rise over run. So 1, 2, 3, 4, 5, 6, up is positive. 1, 2, 3, right is positive, rise is 6, run is 3, average rate of change is 2. Question there. Tucker, you done? Yeah. Okay. I think I took up your warm-up. If you want to grab it again, sorry about that. Okay. Number 3, we are doing average rate of change again. And finding the average rate of change with an equation seems to be the hardest for the students. But what we've got to remember is all we're doing is plugging in the x values to get a y, and that's how we get the ordered pairs. So, I mean, if you're wanting to take notes here, you're going to plug in the x's to get the y's. Then you're going to use your ordered pairs, and you're going to do. Okay? So, first thing we need is we need to find g of -2. Next thing we need is to find g of 5. Okay, so what does it sound like? Negative blank squared minus blank plus 6. So I'm going to do my setup. Negative blank squared minus blank plus 6. Negative blank squared minus blank plus 6. Negative blank squared minus blank plus 6. So on this first line, what do I plug into the blanks? -2. And on the second line, what do I plug into the blanks? 5. Okay, I'm going to do this without a calculator. Obviously, with a calculator, these are negatives, not minus signs. With a calculator, you'd put it in exactly the way you see it, but again, I think some of this would be non-calculator on a standardized test, so I want to show you how to do it without. First thing we do is square the -2, and we get a 4, and then there's a negative out in front. So that's a -4. Minus a negative is plus, so that's +2 plus 6. So I have -4 plus 2 plus 6, and that equals 4. So I just found an ordered pair that is a solution to this function. It's the ordered pair -2, 4. So I got one ordered pair. Now I need another one. 5 squared is 25, and then we tack the negative on at the end because it's outside of the parenthesis. Minus 5 plus 6. When I put all that together, I get -24. So I created another ordered pair, the ordered pair 5, -24. And now, remember, we're finding the average rate of change, so that's the slope. I'm going to do down, up, down, up. When I combine here, I get a 28. When I combine here, I get a -7. When I simplify, I get a -4. So the average rate of change over the intervals -2 to 5 is -4. Y'all, we really need to be able to do this. I know that one is very lengthy as far as math goes. A lot of math involved. They only give you the X part of the ordered pairs. You've got to plug in to get the Y's. And then you've got to do. Okay. Question on that? All right. Let's flip over. Okay. This is a problem that was from the released EOC from a few years ago. You can tell because it's still got the released words on it. Dennis compared the y-intercepts. So key phrase here, y'all, is y-intercepts. Okay, now let's see what it says. What is the difference when the y-intercept of f of x is subtracted from? Okay, that's a key phrase there. Is subtracted from the y-intercept of g of x. So there's two different functions. Here's f of x, and the y-intercept is 5. G of x does not have a y-intercept listed, but we can look at some patterns and see if we can figure it out. Let's look at the x's. It looks like we're adding 2 each time. So -7, 6, 5, 4, 3, 2, 1, 0, 1 would be the next in the pattern. 2, 3, 4, 5, 6. Okay, we've still got a problem. Y-intercept is where x is 0. That is right in the middle there. Remember, this is linear, so it's right in the middle is where the x would be 0. So I've got to go right in the middle. What number is between 5 and 6? What number is exactly in the middle of 5 and 6? No, it's not a number you like, but it's 5.5, y'all. The number halfway between 5 and 6 is 5.5. So it's 5.5. Okay, so we've got 5 and we've got 5.5, and I'll tell you, subtracted from means switch the front to the back and the back to the front. So the f of x is the one being subtracted from, and the y-intercept of f of x is 5. Y-intercept of g of x is 5.5. And when I subtract 5.5 minus 5, I just get 0.5. Y'all, the hard part here is realizing you gotta work on this to get to your y-intercept in that table. Okay? The next thing we have to realize is we're comparing two things. I know when we were doing some comparison last week, people didn't even realize there was another function up there, because you guys have a tendency to skip over those words. We good? Okay. All right, last one. Unfortunately, for the viewers at home, you're not going to be able to see this on Desmos. But what I told you to do, first of all, let's just read the problem. The function f of x equals 2 times 2 raised to the x was replaced with f of x with something added to it. Okay? So resulting in the function that was graphed. So they're asking us what was added to it. So y'all, I gave you a hint because we haven't learned this. The hint was, notice I've added some things. And I told you to go in Desmos to see what was going on. Okay? So, I'm going to do that. Okay, so I'm going to do y equals 2, parentheses, 2, close it, raised to the x. And if you'll notice, y'all, that's the original function. Look where this asymptote is, y'all. Where's this asymptote? It's at y equals 0. Do you see that? It's coming right down to the x-axis and staying right there. Okay, so let's see what happens when I do the first one in the hint. Y equals 2, parentheses, 2, raised to the x, and now I'm going to add 3 to it. What just happened? Besides the fact that my projector went off. What just happened?
It made another.
Okay, but where did it go is what I'm getting at. It made the exact function, but something happened from red to blue. Okay, look what happened. The y-intercept went from 2 to 3 to 4 to 5. Went up 3, look at your asymptote. It was here at 0, now it's at 3. Everything did what? Moved up 3. Okay? We could go put another one in. Y equals 2, parentheses, 2, raised to the x, minus 1. What happened to the asymptote from here to here? What happened to the graph?
Moved down 1.
Moved down 1. So y'all, this little number that's being added and subtracted on the end of the function is moving this thing up and down. Okay, so now let's go back and take a look at the original problem. Original function has the asymptote coming along right here. How many has this thing shifted down? The original function has the asymptote coming down to the 0.
5.
It has shifted down 5. So what would you put on the end of this to get it to go down 5?
Minus 5.
You would put minus 5. So K is negative 5. That's how you would get it to shift down 5. Try to give y'all another one of those. Okay? All right. Y'all, we are going to do some more factoring methods today. So if you all would get out your notebooks, we're actually going to fill out the right side of our notebook from the last page we were on. Okay? Y'all can close your Chromebooks. We're not going to use them anymore. We may do some whiteboard practice in a little bit. I just want to get this one part of the So this is what I want you guys to do. If you will, let's come over about halfway. Let's go about halfway down the page, and we're going to block off this little guy. And if you wanted it to be a little bit more visible, there she is. Okay, and for this, and I'm going to try to squeeze 3 of these in here, so you might want to make sure you write way up here. For this first little box, we've actually already done this. We are going to convert from factored form to standard form. And we have already done this. I just want it in your notebook and want to refresh your memory about it. Okay? Factored form to standard form, and then on the rest of it, that's the new stuff, most of it. On the rest of it, we're going to convert from standard form to factored form. So we're going to go backwards. Okay? Okay, so hopefully you're going to recognize a lot of this. Okay, let's do an example. And again, try to give yourself a lot of room here. Okay, -2, and in parentheses, x minus 7. And then in the next parentheses, x plus 3. There is nothing in between the two parentheses, so this is multiplication. This is multiplication to get it into standard form. So the first thing we're going to do is a 2x2 box to multiply, and then the last step is going to be to multiply everything through by -2. Okay, so again, let's give ourselves not too much room so we can get a lot of this done. Okay, so we're going to put an x and a -7 up top. We're going to put an x and a 3 along the side. And we're multiplying, so we're adding powers. So x times x is x squared. X times -7 is -7x. Then we've got 3x. Then we've got -21. Who knows what we do next? Yep, we're going to combine the like terms, the -7x and the positive 3x. Give me -4x. I'm going to bring down my x squared, bring down my -21. Now I'm not done because right out here in front is a -2. So I'm going to need to multiply all the way through by -2. So -2 times x squared is -2x squared. -2 times -4x is positive 8x. And -2 times -21 is a positive 42. So look what we did. This was factored form, and we just converted it to standard form. Okay? Now, we've been doing that. I want to do 2 more so you can see some odd-looking ones. I want you to see some odd-looking ones. So I'm going to do 2 more examples. I'm going to pause for a minute to make sure y'all got that. Okay? Okay, so let's do 2 more. I'm going to get them kind of separated for you so you can see where we're going. Okay, so those last 2 examples we're going to put in this box. So give yourself a little space. Boom, boom. Okay, 2x2 box here. So a 2x2 box here. Put an x and a -3 up top, an x and a positive 3 down bottom. And now we're going to multiply. We get x squared, -3x, positive 3x, -9. Now, when we combine terms, what happens here? 3x minus 3x is gone, y'all. 3x minus 3x is gone. You're left with x squared minus 9. So I wanted you guys to see that. So check it out. This is your standard form. You got an x squared term, you got a linear term, you got a constant. The constant term just disappeared here. Look at the factored form and look at this. What do you notice up here about this factored form? What do you notice about these two terms? Or the binomials? What do you notice? Come on, folks. What do you notice? Same numbers on the end. One's minus and one's plus. Y'all, that's what happens. The middle term will disappear when you have that. Okay? All right. Next one I want to do is this one. Notice there's an x minus 4 that is squared. Y'all, the one thing the students have a hard time remembering is that all that means is write x minus 4 twice. Squared means you multiply it times itself. So this is what it really looks like. 3 with an x minus 4 and another x minus 4. And then plus 5. So y'all, that right there is just x minus 4 multiplied times itself. So we're going to do a 2 by 2 box. Then what are we going to do after we get that part? Somebody help me, there's more to do. After we do the 2 by 2 box with this, what are we going to do? We're going to multiply by 3. And then what? Add 5. Okay, so let's do our 2 by 2 box. We have an x and a negative 4 and an x and a negative 4. Now, y'all, these middle terms aren't going to disappear. They're not different signs. They're the same signs. And, y'all, that's what happens when they just write it in a condensed form, when they just put a square on it. So we've got x squared, negative 4x, negative 4x, and a positive 16. When I combine a negative 4x and a negative 4x, I get a negative 8x. I'm going to bring down my x squared. I'm going to bring down my plus 16. I've got to multiply that whole thing by 3. And then when I get done with all of that, I'm going to add 5 to it. So notice those little details up here. Multiply by 3, add 5. So we're going to distribute here. 3 times x squared is 3x squared. 3 times negative 8x is negative 24x. 3 times 16 is, let's see, 48. And then I'm going to add 5. So the final answer is 3x squared minus 24x plus 53, I'm pretty certain. Okay, so again, notice this is factored form. That's factored form. That's standard form. Okay, so y'all, this particular stuff here really isn't new. We've been doing this. Okay, now we're going to do something that we did last week. Okay, so now we're going the other way, y'all. We're going to do standard form back to factored form. Okay, so the first method we did last week, it's the greatest common factor method. So we're going to put one in your notebook to have. It's the greatest common factor method. Okay, so here's an example. 4x cubed y minus 2x squared y squared plus 10xy cubed. We're going to factor that. 4x cubed y minus 2x squared y squared plus 10xy cubed. So y'all, if we're going to factor by the greatest common factor method, we got to find the greatest common factor. So I need y'all to help me with it. Need the greatest common factor. Let's start with coefficients. 4, 2, and 10. It's 2. Now, y'all come on down. Leave yourself some room. Remember, we got to divide up here. So, leave yourself a little bit of room. A 2. Okay, tell me about the variables. X shows up in all 3. I pick the smallest power. Okay, tell me about the Y's. Y shows up in all 3. I pick the smallest power. I set up one parenthesis and make it a big one. I'm going to go ahead and bring my minus sign down to make some slots and bring my plus sign down to make some slots. What do I do now? I divide everything by 2xy. I divide every term by 2xy. I'm going to put it in a highlighter. Okay. So divide by 2xy, divide by 2xy, divide by 2xy. So when I divide this first term, I get a 2. I subtract powers, so that's going to be 2x squared. Do I put a y in that slot? No, I do not. Y's cancel. 2's cancel, so technically that's a 1. When I subtract, I have an x to the first power. When I subtract, I have a y to the first power. Last term, 10 divided by 2 is 5. What happens to the x's? They cancel, so I do not write an x. And then when I subtract powers on the y, I get a y squared. Okay, factored form, standard form. That's what we did last week. Okay. Now, the new stuff that we're going to be doing this week, we are still going from standard form to factored form, but we are going to use the box method. And yes, it's going to be a 2x2 box, but instead of writing stuff on the outside and multiplying to the inside, y'all, we're recording stuff on the inside and we're working our way to the outside. We're going in reverse. Okay? So a couple of things. Had some folks make me some golden rules for factoring up here. We always want to pull out a GCF first if it has one, and if that leading coefficient is a -1, y'all, you've got to pull it out. Okay? And we'll do a few of those examples. I'm going to start off with one that's not an example like that, but let's at least get it in our notes. Pull out GCF first. And y'all, it may not have one. Okay? You just need to know if it does, you got to pull it out. Okay? If leading coefficient, that's the one on the x squared term, if leading coefficient is negative, you're going to pull out -1 as a GCF. Okay? So pull out a greatest common factor if it's there. If the leading coefficient is negative, you got to pull out a -1. We got to try to get rid of it, in other words. Get it out of the way. Okay, so let's do an example here. Big deal here, y'all. Factoring trinomials is a big deal. We're going to factor x squared minus 6x minus 16. Okay? First of all, is there a greatest common factor in those three terms? In other words, is there a coefficient out in front that's bigger than 1 that'll go into everything? It's not, because the leading term has a 1 in front of it, so there's nothing. Is there an x in all three terms? Nope. So, y'all, there is no GCF here. So now we're going to use the box method. So watch carefully. This is a long process. Okay, so we want to leave ourselves a little bit of room up top and on the side. We're going to do us a 2x2 box. Okay. The first term goes in the top left box. The last term goes in the bottom right box. We multiply these together. And the reason why it's important is because, y'all, this number's not always going to be a 1. Okay? We multiply these two together, and we're going to come over here, and we're going to write negative 16. Okay? There is an x squared, and it breaks down as x and x. So you could go ahead and put the x's in these boxes. And, y'all, if you forget that, it's going to mess you up. So I'll say again, negative 16, when I multiply these together, I get negative 16x squared. I need the factors. Well, the factors for x squared are x and x, so I go ahead and put those in the box. Okay? So, y'all, I need, and you guys did this fun little X box, I need magic numbers that multiply to get to negative 16, but combine to get negative 6. So, y'all, if you remember when we were doing those puzzles where you had to multiply to get to the top, but combine to get to the bottom, this is where you were headed with that. So I need the magic numbers that we multiply to get to negative 16, but they combine to get to negative 6. I need the magic numbers. Something times something. Somebody give me some numbers that multiply to get to 16. Let's just not even worry about the negative. What times 1 will give me 16? 8 and 2. And if it's negative 16, one sign's got to be positive and one sign's got to be negative, right? Which means we're subtracting. What is 8 minus 2?
6.
So that's probably going to get us there. But we got to have the signs on the right stuff. It's going to be a negative 8 and a positive 2. So let's think about that. When I multiply negative 8 times positive 2, I get negative 16. When I combine negative 8 and positive 2, I get negative 6. So these are my magic numbers, and they go in these other two boxes. And y'all, if you remember over here, the stuff was on the outside, and we multiplied to get to the inside. We're actually finding greatest common factors to get the outside now, okay? So, I need a greatest common factor between these two terms. Everybody watch, this is important. I need a greatest common factor between those two terms. One what? See how there's an X in both? So y'all, I'm not going to worry about the one part, but I'm going to pull the X out right there. Okay, I need the greatest common factor across these two. It's 2. Do I pull an X out?
No.
Is X a common factor between these two terms? No, because X doesn't show up there. It's just a 2. So I'm going to pull a 2 out here. Okay, y'all, now we're going to do the same thing here. And it's going to go up here. Do you see how, y'all, when we were doing factor to standard, we started here and filled in the box. Now we've started inside the box. We're pulling greatest common factors out. Okay, so between x squared and 2x, what is my common factor, my greatest common factor?
1.
1 what? 1x. I'm not going to worry about the 1. I'm just going to pull out the x. Okay, here, what's my greatest common factor?
2.
There's a big one.
8.
It's 8. Do you see how there's a negative in both, y'all? Y'all see that? I'm going to pull out, when the negative is in both, I'm going to pull it out. So I'm pulling out a negative 8 here. Okay. There's our factors. Here's one parenthesis. Here's the other. So check this out. Okay, I know the sign with the 8. It's x minus 8. I don't know the sign with the 2. But what we need to do is we come over here. What were my signs? They were different. They were different. My signs in here have to be different. You can even look here. My signs were different. My signs need to be different. Do you see how we already figured out which one was minus? Because it showed up twice. So if the signs need to be different, this is going to be plus. And there is your factored form. There's your factored form. Okay? All right, let's do another example. And I'm on the right side. I'm saving room because I'm going to come over here when I get down to the bottom of this. So let's do another one. X squared plus 8x plus 16. Do I have a greatest common factor among those three terms? I do not. Remember, we always have to check that. Leading coefficient is not negative. I'm in good shape. So now I'm going to save myself some room here, and I'm going to set up a 2x2 box. First term goes top left. Last term goes bottom right. I multiply the two together. Y'all, something I can automatically put in these two boxes. Just automatically I need to put it in. I need to go ahead and put those X's in. Okay? So now I am looking for the magic numbers that multiply to get to 16 but add to get to 8. Do you see I'm pulling that middle term in? Magic numbers that multiply to get to 16 but add to get to 8. Tucker? 4 and 4. Because 4 times 4 is a positive 16. 4 plus 4 is an 8. So that's what goes in these two boxes. Okay, now we're pulling out greatest common factors. So let's come this way. Greatest common factor here. Not 4. 1 what? So an X comes out right there. Okay, how about between these guys? 4 comes out there. So we pulled out a greatest common factor of X and a greatest common factor of 4. Okay, now let's come up here, straight up. GCF for these two. Put an X, GCF for these two.
4.
Okay, so we've got an X and a 4. Okay, we're going to set up 2 parentheses for our factors. We've got an X and a 4. We've got an X and a 4. We've got no signs. So I'm going to look right here. Or I'm going to look right here. What were my signs on these? Both of them were positive. Both signs in here are positive. And just so you know, since these are the same factors, you can write it in condensed form. X plus 4 squared. This and this are the same thing. These two are the same thing. This is a condensed way of writing it where it looks better. All right. Good. Okay. I am out of room. I'm just going to come up here. I'm going to come up here. Okay. X squared minus 49. Okay, so I'm going to set up, I'm going to leave me a little bit of room. I'm going to set up my 2x2 box. First term goes top left. Last term goes bottom right. I can go ahead and put my X's here. Okay. So now I have negative 49 that I need to multiply by, and I go to look for my middle term, it's not there. The middle term is not there. So I am looking for the magic numbers that multiply to give me negative 49, but when I add them together, they cancel out. I get 0. Say again, I'm looking for the magic numbers that multiply to get me to negative 49, but when I add them together, I get 0.
Negative 77.
It's negative 7 and positive 7. 7 times 7 is?
49.
Negative 7 added to positive 7 is 0. So it is a negative 7 and a positive 7 are the magic numbers that go in here. And by the way, y'all, when you get these two numbers, it doesn't matter which spot here you put them in. It doesn't matter. It's still going to work out. All right, we need greatest common factor. So these two. 1 what?
X.
Okay, so I'm going to pull an X out. Greatest common factor here. 7. Greatest common factor up.
X.
Okay. Greatest common factor here.
7.
And what do I do when I see both negatives? Negatives in both terms.
Negative positive.
No. No, I pull the negative out with it. You know, common factor, greatest common factor. Y'all, if the negative is in common, you pull it out because it's going to help us. Okay, so I've got my two parentheses. I've got an X and a 7 that I don't know the sign for, and then my other factor is X minus 7. How do I figure out my signs? I look right here. The signs are different. Signs have to be different. So what needs to go there? A positive. Y'all take notice. Middle term is missing. What do you notice about these factors?
It gets well.
Different signs, but same numbers in the slots. Y'all, this is called a difference of squares. This is called a difference of squares. The reason why is those are the same numbers. They're perfect squares. Okay? All right. Okay, let's do one last one. And then we'll do some practice on the whiteboards. Okay. 5d squared minus 18d minus 8. I'm going to save some room. Just come way on down here. All right. You guys will try to get part of this started before I do it. What goes in this box?
5d squared.
What goes in that box?
Negative 8.
Okay. Y'all want to try to do it without me first? Where I'm kind of guiding you a little bit. First term goes top left. Last term goes bottom right. What do I do with those two terms? Multiply them together. $5d squared goes here. Negative 8 goes here. What can I go ahead and put in these other two boxes? D's. This particular problem gave you D's. Okay, when I multiply these two together, what do I get? Negative 40. And d squared is correct, but the reason why I'm not putting it there is because I already broke the d squared down. Look, d times d. Okay, what number, I know I'm trying to multiply to get to negative 40, but what number am I trying to add to get to, or combine? That's where the middle term comes in, y'all. I'm trying to add to get to negative 18. So I'm going to give y'all a minute. If you need some numbers, you can go to y equals in your calculator. I think I told y'all about this last week. If you go to your calculator and you go to y equals, make sure everything's cleaned out, you can put negative 40 divided by x in your calculator. So calculator, y equals button, put negative 40 divided by x, and go look at the table. If you need a list of factors, that is the trick. Again, these would be calculator inactive on a standardized test. You would be expected to come up with the factor for negative 40, the magic numbers, without a calculator. So I can demonstrate that for those of you that, okay? So let me demonstrate that for y'all. So if you go to y equals, by the way, y'all, you got to clear out everything else. Okay, put in negative 40 divided by x, and x is right here. And y'all, the table is up here. Your table is in yellow, so you got to press that second. You got to press your yellow button and table. Y'all, this is a list of factors. 4 times negative 10. 5 times negative 8. Notice they switched the sign around. 8 times negative 5. Positive 10 times negative 4. You don't mess with the decimals. And if you don't see what you need, you can scroll down more to see if there's more. Right there's 1. There's 20 and negative 2. And I'll go ahead and tell you, folks, once you get to the halfway point, there's no need to go any further. There's nothing else that's going to go in it. Okay? 20 and 2, there's nothing bigger than 20 that'll go in it. But what am I looking for? I'm trying to get to negative 18. Wait a minute, I think we did. That's not going to get us to negative 18. That's going to get us to positive 18. What do I do to get to negative 18?
Add 2 negatives.
Well, if I combine right now, I get a positive 18. There's one thing I can do to fix it. Thought it was obvious.
What was the question? What was the question?
That when I combine, I get to negative 18. These two numbers are it, but the problem is when I combine them, I don't get negative 18, I get positive 18. What can I do to fix that problem? Flip the signs. Negative 20 and positive 2. And by the way, if you scroll up, it's up there. It's right there. Okay? So we need, the magic numbers are negative 20 and positive 2. Okay? See if y'all can do greatest common factor, greatest common factor, greatest common factor, and greatest common factor. See if y'all can do it without me. Pull out your GCS. Boom, boom, boom. Greatest common factors. Okay. Let's go across this way. Greatest common factor across the first row. Anybody give it to me louder where I can hear? Greatest common factor.
4.
Not 4, because 4 won't go into 5. You're almost there. You picked the wrong number.
5.
5 what?
X.
D. Okay, how about here?
2.
2. How about here? Here? 8 will not go into either one of those.
4.
4 won't go into either one of these. Is it possible it could just be a 1?
Yeah.
Okay. 1 what?
D.
Thank you. It's just a D, y'all. Okay, how about here?
Oh, 4.
It's 4, because 8's not going to go into 20. It's gonna be 4. What else do I need to remember for this one?
Negative.
Pull that negative out. All right, I'm ready to write my answer. I'm gonna set up 2 parentheses. I got a 5D and 2. I got a D minus 4. My signs are different. So what needs to go there?
Positive.
There's your factored form. That's what we're going to be doing this week. Right there. Okay, so here we go. All right. Somebody gonna probably need your notes out. See some folks already getting started. Y'all running a little bit. Y'all running a little bit slow.
I'm pretty big, I can't.
Do you understand what I mean?
Yeah,
Okay.
sorry.
Well, I mean, it's not really funny, is it?
No, I didn't laugh.
Margoni, pack up your stuff in the office. I don't want a bigger box stuff in.
I got it.
Folks, I see a few of y'all at least got your boxes and ready to go. What's gonna go in this top left? Huh? First term goes in the top left. What goes in the bottom right? What goes in the bottom right? 20. Technically, don't forget, you're multiplying those 2 things together, but you don't have to worry about it with this. You just put your X's in the box. You probably want to do a bigger box from now on, Justice. It's kind of, we might have a hard time fitting stuff in there. Okay, folks, at some point, I've got to let you guys loose. If I keep filling in this stuff for you, you're going to stop thinking. Okay, so I told you x squared goes here, 20 goes here. When you multiply, you get 20x squared, so you need a 20 in the top here. What do you need right there? Now you're looking for the magic numbers. That's the hard part. Let's find the magic numbers. Let's find the magic numbers. Yeah, you put, you put divided by x. Not divided by -9. You put divided by x. And when you go to your table, you'll get to see a list of stuff. And if you can do it without that calculator, it will be very helpful. Hey y'all, if you're struggling, just forget all about the -9 and write every factor every set of factors to get you to 20.
Does it have to be a negative?
It sure is. Yes. Check this out. When I multiply -5 times -4, what do I get? When I add -4 and -5, what do They both have to be negative, because what happens when you multiply negative times a negative, you get a positive. What happens when you add negatives, you get a negative. So they're both negative. Did y'all find your numbers?
Yes.
Okay, why don't you just stop right there?
Why did you?
What happens when I add those numbers together? Okay, I just need them to be negative, so what signs need to be on both of those? So you got a -5 and a -4. Notice, when I multiply negative times negative, I get positive 20. When I add negative 4 and negative 5, I get negative 9. You about to get it. You find it? Okay. What do I get when I add 4 and 5 together?
9.
What do I get when I add negative 4 and negative 5 together?
9. Negative 5.
And you need to put your 20 there. That's it. Ladies, good job. And it doesn't matter which one of these comes first, like that could be on the other side. Oh,
Wait, this
How do you know?
okay, the part you miss is you have to pull out a greatest common factor, greatest common factor. And by the way, it's not 10 and 1. Here's the problem with the, when you multiply a negative 10 times a 1, you don't get negative 20. See, you need to put divided by x here,
Okay, but what's the negative 10?
divided by
This
x.
would be negative 20, so this one has to be.
And now when you go to your table,
So let's see if it adds.
Okay, you better put this one too. I'm not-
Yes, negative 12,
you do negative 5 and negative 4. They don't come to that. Y'all see it filling your print. Be careful that you don't add negatives here when they don't show up twice. Now, here's the deal. You're gonna end up making them negative. I just wanted you to know that you're gonna pull negatives out when they don't show up twice. But when you fill in and you come over here and look, both are signs negative.
How much is it?
Like I did. That's it. Okay. It sure is. Good job. Okay, folks. Okay, folks, if I could get everybody to stop talking for a minute. If I could get everybody to stop talking for a minute. I do have a couple important things to tell you about this. When you multiply these together, let's go ahead and put X's there. When you multiply these together, I am trying to combine to get to a negative 9. It's negative 5 and negative 4. Okay, so I'm going to pop this in here. Okay, y'all, something I noticed with some folks. Y'all, when you're doing a greatest common factor, if the minus sign is not in both, don't pull it out. Okay? So GCF here is 4, GCF there is X, GCF here is 5. Okay, so we have two parentheses. We've got an X and a 4, we've got an X and a 5. I don't know what signs go here, but when I look here, what were my signs?
Negative.
See, what I'm worried about, y'all, is if you get in the habit of seeing a negative and pulling it out here, when we get to some of those problems I just did, you're going to have the wrong signs, okay? But there's your answer. And y'all, the X minus 4 can be in the back. It doesn't matter, okay? All right, let's try another one. Okay? Okay. I'm going to set up my 2x2 box. N squared goes top left, negative 14 goes bottom right. I'm just going to go ahead and put my n's here. When I multiply, that's a 1, so it doesn't really change much. I need to multiply to get to negative 14 and add to get to negative 5. Many of y'all found the numbers. The numbers are negative 7 and positive 2. When I add those, I get a negative 5. When I multiply those, I get a negative 14. Now, if you had your negative 7 here, it doesn't matter. You're going to see how it works. So just check this out. GCF here is N. GCF here is 2, GCF here is N, GCF here is -7. Y'all, if you switch these two, what happened was your N and 7 were over here, and your N and 2 were up here, and it doesn't matter. Okay? So now, when I set up my parentheses, I've got an N and a 2, and an N -7. I need different signs, so that's going to be positive. This is the same thing. It's the same thing. We good? Yeah? Okay. Okay? X squared minus 25. Okay, here's the problem. There's no middle term, 0. Y'all, the middle term is missing, so your numbers have to add to get to 0. Middle term is missing. We'll come over here and take a peek. You hadn't done the greatest common factor. So between these, the greatest common factor. You can't see the limits. Okay. Now, wait a minute. That's not right. Okay. Okay. No. 5 times 5 gives you 25. So you need a positive 5 and a negative 5. What's 48? Make one of those 5 and that's a negative 5. Because when you add them, okay, now GCF here's X, here's your GCF here. GCF here, okay, GCF here. And since negative shows that we both pull it out, now you're ready to go. Yeah. 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 Almost. The numbers were -5, +5. Folks, I want to show you something. This is called a perfect square. The reason why it's called a perfect square is because the same numbers can be, if you guys will listen, y'all, this is called a difference of perfect squares. The pattern you're seeing for that does work. So you'll get to the point to where when you see the difference of squares, you won't even need all this. You'll know what to put there. Okay? So the magic numbers are -5 times +5. And when we do when we pull out our GCFs, we find out we've got one that's +5 and one that's -5. Okay, now I want y'all to not use your boxes. I want y'all to look at this and this. Okay, do y'all see this and this? I want you to try not to use your boxes and see if you can fill this in. I want y'all to try not to use your boxes. You ready? Okay, do you see the pattern? Look right here. And it's happening when there's no middle term and when there's a minus sign here. I want you to see if you can go from here to here without the boxes. So I'm already setting it up, okay? I want to see if you can go from top to bottom without the boxes. Tucker, top to bottom without the boxes. From here to there with no boxes. That's it. That's it. That's it.
Sorry.
That's it. Okay. Okay, folks, the key, if you look at the one on the left, look at what's in parentheses. Tell me about those two numbers at the end of each parenthesis on the left side. They're the same number. Look at your numbers. Look at your numbers. Do you see what I'm saying? Is that y'all? That's not y'all. That's it. So y'all notice, everybody, let me show y'all a trick. Everybody, let me show y'all. Everybody, look. See your square root button in yellow? Everybody do second square root and put 36 in there. Oh, that is y'all. Hey folks, if you'll come up and put your boys up for me.